This is lesson 4.3, graphing cubic functions. So first, we'll start out with a basic cubic function. We'll use the table to graph the parent function f of x is equal to x to the power of 3. So we have f of x equals x to the power of 3 when x is equal to negative 2. We have negative 2 times to the power of 3. Negative 2 to the power of 3 is negative 8. So here on the graph, when x equals negative 2, y equals negative 8. So we'll graph it right here at this point. I'll fill in the rest of these. And 0 to the power of anything is 0. 1 is 1. And 2, positive 2 is going to be positive 8. So I'll graph those points. The center at 0, 0, negative 1, positive 1, positive 1, and positive 2 to positive 8. Now we have this shape here. And this is what the parent function of a cubic function looks like. Now for these examples, we're just going to state the end behavior for each graph. So as x moves towards negative infinity, so as it moves this way, the y value is moving down. F of x moves to negative infinity. And as x moves towards positive infinity, so it's going this way, f of x moves towards positive infinity. As x moves towards negative infinity, this way, f of x moves towards positive infinity, because as it moves this way, it's going up. As x moves towards positive infinity, this way, f of x moves up. So both of these move in a positive direction. We see here that it's opening upwards. As x moves towards negative infinity, this way, f of x moves where? So we see that it starts here at this point, then it heads down, but they're asking for the end behavior, and then it heads back up towards positive infinity. And as it moves to the right, once again the graph heads down, but it goes right back up. So this also moves towards positive infinity. Transformations we explore with quadratic functions can also be applied to cubic functions. This time, we're raising it to the power of the third, and the vertex we're calling the center of the equation. So for this first example, we'll graph the function based off of the parent function. F of x is equal to x to the power of 3. So here, we'll write out our transformations. We have a reflection because the a is negative. We see here by this negative sign in front of the x cubed. We know that we have a shift upwards by 3, and that's seen here in our k value, which equals positive 3. We can write our center as 0, 3, because there's no h value, and we know that our k is equal to 3. So we'll write our center at 0, 3, right here. And because there's a reflection, it's going to go this way. So it's moving sort of in the reverse, where the original looks like this. For the second example, we'll write out some transformations. So we know that it's going to shift left by 4. And we know this because h equals -4 with this value here. And it's going to shift down by 2. We know this because our k value equals -2. We have our h and our k, so the center will be located at -4, -2. So let's plot that. -4, -2. Right about there. There's no reflection or stretch, so the shape of this function looks generally similar to the original, only shifted down and to the left. We can use f of x is equal to positive or negative a times x minus h cubed plus k to help us graph a cubic function. We also use reference points. So the steps here is to find the center point, which we know is hk, then we'll identify if there's any sort of stretch, compression, or reflections. And we'll use our reference points to help you graph a function. So the reference points, I do 1 unit to the left and 1 unit to the right from the center. So if the center is at 1, 1 unit to the left is 0, and 1 unit to the right is 2. So first, let's identify the center point. We see this here. It tells us that our h value is 10. There's nothing where the k would be, so we know that k is equal to 0. So the center is at positive 10, 0. So written also in the xy format, we can put our 0 here, and f of x equals 10. In the xy format, we can put a 10 here and a 0 here. And if we go 1 unit to the left, we'll go to 9, and 1 unit to the right is 11. Next, we'll plug this x value in to this equation to find f of x. So f of 9 equals 2 times 9 minus 10 cubed. 9 minus 10 cubed equals 2 times -1 cubed, which equals -2. And for f of 11, 2 times 11 minus 10 cubed equals 2 times positive 1 cubed equals positive 2. So here to identify our center, we see our h value here. So h is equal to -1, and our k value here, k is equal to -66. So this way, our center is equal to -1, -66. So we'll start our center here in this middle row. X is -1, and f of x is 66. So 1 to the left is -2, and 1 to the right is 0. So f of -2 equals -2 plus 1 to the power of 3 minus 66, which equals -65. of 0, negative 0 plus 1 to the power of 3 minus 66 equals negative 67. So for these last two examples, we'll use reference points from the graphs to determine the cubic function. So first, we see that our center is at 2, 1. So we know that our h value equals 2 and our k equals 1. In our format of f of x is equal to a times x minus h, actually plus or minus h to the power of 3 plus or minus k. We can put those values in. So we have f of x is equal to a k minus h, because we take the opposite. If this is positive here, we'll put a negative sign. H is 2 to the power of 3 plus 1. Now that we have our h and our k, we can find if there's an a value here using a coordinate that we're given. So let's use 3 and 4. So f of x is our y coordinate, so I'll set 4 equal to a, and then x here is 3. 3 minus 2 to the power of 3 plus 1. Now we'll solve for a. So we have 4, a, 1 to the power of 3 plus 1. So we'll subtract 1 on both sides. So we have 3 equals a, and 1 cubed is just 1, so 3 equals a. So we can put this 3 back into our equation. So we have f of x equals 3 times x minus 2 cubed plus 1. We'll use the same approach here. I'm not sure how clear the numbers are, but I'll write it for you, that the center is at 4, 0. So if the center is at 4, 0, it crosses this line here at, this is 5, 2. So the same method as last time. We'll set it up in this f of x format. Plus or minus h cubed plus or minus k. We have no k value as that equals 0. So we have f of x equals a x minus 4 cubed. Now to solve for a, we'll do the method as last time. 2 equals a times x, 5 minus 4 to the power of 3. We're using this coordinate to find a. So 2, oh my goodness. 2 equals a 1/3. So f of x equals 2 times x minus 4 cubed. Now for both these examples, we mathematically solved for a, but as you see here, based off of the parent function, where it should go from this point to 1 point, we see that there's a stretch of 2 units, so that would make a equals 2. But this way we can prove it, mathematically. In this part, a equals 3, and we see that it shifts up 3 units, or it stretches by 3 units.